Why would the quietest, hardest to catch particles in the universe also be its most perfectly shaped loop? In the energy filament theory, the neutrino is not a weak little ghost tagged on at the edge of physics. It is the cleanest, most economical way the energy sea can curl itself into a loop and still count as a particle. So clean that the sea barely reacts to it and almost nothing can grab hold of it. Start with a picture you already met in the last episode. Imagine throwing a tiny ring into water. If one side of the ring is pulled tighter, the water on that side tends to crowd in, while the opposite side tends to shove water away. That asymmetry is like an electron, which from the outside looks charged, with one side of its loop pulling the energy sea inward and the other pushing it outward. Now imagine a ring that is almost perfectly balanced, pulled equally hard in every direction. The water neither rushes towards it nor clearly avoids it, and if it slips past you under the surface you hardly feel a thing. That is the neutrino, a loop whose inner and outer tensions are nearly identical, so it does not create a net inward or outward tug on the sea. Because the pull is so symmetric, the neutrino does not carve long, straight lines of tension into the sea around it, so it does not create a noticeable electric field. Even when it races along at high speed, it has no strong bundle of straight textures to twist into a swirling pattern, so it barely drags out a magnetic field either. From the outside it looks almost textureless. Its tiny mass comes from the same simplicity. Think of people standing on a soft mattress. A heavy person presses a deep hollow and is hard to shove sideways, because you must drag that hollow with them. A very light person barely dents the surface and is easy to move. The neutrino is like that light person. Its loop disturbs the sea so little that it creates only a very shallow dent in the tension landscape, so shifting it requires almost no work against the media. And we experience that as a mass that is small enough to be tricky to pin down. Its legendary unwillingness to interact with anything has the same root cause: the loop is too clean and smooth. Most interactions rely on the teeth of one particle's texture catching the teeth of another, like two pieces of Velcro. The neutrino's loop has almost no ridges or directional scars around it, so there is nothing for electric or strong nuclear textures to latch onto. You can think of it as an extremely smooth droplet skimming across water. It leaves almost no wake, barely stretches the surface, and once it has passed, the surface looks as if nothing went by. That is why a neutrino can fly straight through an entire planet with almost no chance of being stopped. It is not magical, it is just that most of the usual interaction channels electric field hooks. Strong force grooves have nothing to grip. Only the very weak forces at short ranges and gravity at huge scales whisper at it from afar. In that sense, the neutrino is a long-distance runner with almost no drag, always present but rarely noticed. There are enormous numbers of them, crossing galaxies and slipping through your body right now, quietly taking part in the bookkeeping of energy and momentum without ever putting on a big show. As a theoretical benchmark, the neutrino is the minimal loop, a design where the sea is curled just enough to make a genuine particle, but with almost no extra twisting, no extra textures, no extra dents. From that baseline you can imagine turning knobs. Add a bit more tension and the dent deepens, the effective mass grows. Add directional grooves in the surrounding sea and you get electric field structure and the possibility of charging. Let those grooves twist when the loop moves and you get magnetic effects. Seen this way, masses, charges, fields and forces stop being separated mysteries and become different ways the same sea. And loop systems can be configured on top of a nearly perfect ring like the neutrino. Tap follow, share it on New Physics, Clear Universe.